I'm sick today, so my voice is going to sound funky on here, I think. But um, we do have one question today that actually is off worksheet 7, so you might need that one out too. We're doing, guys, hello, starting class, recording. Okay, piecewise functions, you have to be able to evaluate them, graph them, write the equation of a graph, and tell if they're continuous. Those are the things you have to be able to do today. It says evaluate for these two values, and this is the function. This is kind of a warm-up, okay? You don't have this one. But if I was going to evaluate for -1, which rule would I be using? It says when you're evaluating this, the function h of x works with this rule if it's less than 2, and this rule down here if it's greater than 2. So, yes, less than or equal to 2. So the -1 is less than or equal to 2, so we're going to put it in here. Do 2 times -1 plus 1, which would be what? -1. Okay, then it says to evaluate for 4. 4 is greater than 2, so we're putting it in this rule. So we'd have 4 squared minus 4, or 12, I think, yes? Okay, now this business about continuous. This is a line and this is a parabola. Both of those are continuous, okay? So the only place that this could be discontinuous or jump is at what value of x? Anybody know? What's the value where the rule changes? 2. So the question is, if I put a 2 in, do I get the same value out of both? In other words, do both pieces of the graph match up? Or does it jump? Does that make sense? So if I put a 2 in the top one, I'd get out 5. So that would be a solid circle because of this or equal to. Talk more about that today. If I put a 2 in the bottom one, I'd get out what? 0. So is it continuous? Do they meet up? No, it's discontinuous at that spot. There's some kind of a jump. I used to ask that question on the quiz without having you graph it, like we just talked about, and students didn't do very well. So this year I changed the question. I have you graph one first, and then I ask if it's continuous about that same function rather than talking about a different function. So it'll hopefully help some of you see the discontinuity. All right, so we're supposed to evaluate all of these down here. So real quick, if I put in a 0, it would go in which rule? The first one, so we'd add 2, it would give us a 2. If I put in a 2, it would go in which rule? The second one, so I'd get 4 plus 1 is 5. I put in a 4, it would go in this one, and I'd get out. Okay, to tell if it's continuous, I know if I put a 2 in this rule, this one came out of 5. But if I put a 2 in this, because it goes right up to 2, I would get out what? 4, so it's not continuous. They don't meet up when you graph them. All right, I just wanted to talk about this one because I don't think some of you, well, this symbol is the greatest integer function. Sometimes it just looks like this, and some books use this double thingy like this, okay? It's the one that graphs like a step function. Do you remember this when we talked about parent functions? Okay. The greatest integer function is round down. The rule is you have to give me any, I need the integer less than or equal to this number. So if I put a -10 in, it's actually less than -6, right? So I put it in the top rule. Now be careful because this is also on the quiz. -3, absolute value of 2 plus -10. Are you really clear on absolute value, guys? You have to do what's in here first, so you get -8. Then the absolute value makes it +8, and then you multiply it by this -3, so you'd get out -24. Did I do that right? Everybody okay? I'm going to get that one right because you do have to evaluate an absolute value function on there. 0 falls in here. Everybody with me? So I have to put it in here. Okay. 0 minus 10 is negative 10. Is negative 10 an integer? That means a positive or negative whole number. Yeah. Yes. So it would just stay negative 10. Okay. Put a 2. This is a bad example. Why didn't I use? Okay. Put a 2 in. It's this rule again, right? So 2 minus 10 would be negative 12, and that is an integer. All right. Let me do a couple examples. Negative 8. Yes. Thank you. I'm going with I have a cold, but it's just because I was in a hurry. My bad. You guys are totally right. All right, this is what I want to talk about for a second. What if it was 3.5? Okay, it's between these numbers. I put it in here. Oh, somebody help me. What's 3.5 minus 10? Negative 6.5? Okay, the greatest integer less than or equal to negative 6.5. Keaton is right, because when you have a negative 6.5 and you have to round it down, you're going more negative, right? The next integer to the left on a number line would be negative 7. A little tricky. Let's try positive. Oh, you got to subtract 10? All right, so let's try positive 11.7. That fits in the rule, right? When I put it in and I subtract 10, I get 1.7, but I have to round it down. What does 1.7 round down to? 1. Okay? Because this integer, this notation here is called the greatest integer function or round down. I didn't actually put it on the quiz, but it's good that you see it, okay? It's used, guys, in real life. If you think about it, there's a lot of things that you have to have a whole number answer for, right? If you're buying new microwaves for the school next year because we're merging, right? We were just talking about this in a meeting this morning. So there's going to be more people in our workrooms where the teachers eat lunch. We're going to have to replace some of the microwaves. If you say I'm going to buy one for every 7 people and you come up with 9.4 microwaves, can you buy 9.4 microwaves? No. There's a lot of things in real life that you have to buy an even straight up number. So it's round down function. All right. This is the notes you have in front of you, yes? Is this worksheet 8? 8A? 8B? What is this, 8A? Okay, worksheet 8A. So graphing piecewise functions, this is a hot mess. We are supposed to graph what shapes here? Anybody know this first one? 3x squared is a parabola, right? Negative 1, y equals negative 1 would be, yeah, horizontal line, a constant function. And x minus 5 cubed plus 2 is a cubic function. Now, we could graph each of these independently on the calculator and find some values, but we're going to have to change rules at different places, yes? At negative 1 and at positive 4. Okay, so I'm just going to ignore the rules for a minute. What does 3x squared look like? Give me 4 ordered pairs that would be on this one. I'm going to do this one in red. There's colored pencils in the back if that would help anyone. Otherwise, just use pencil, not pen today. If I put in, it's supposed to be less than negative 1. So let's go with negative 2. Well, we can graph it negative 1, 0, 1, 2. We're going to have to erase a big chunk of it. But if we put those values in, square them, multiply by 3, what's going to come out? 4 times 3 is 12, 3, 0, 3, 12. Okay. So negative 2, 12, negative 1, 3, 0, 0, 1, 3, and 2, 12. So Don't draw this on your paper too firmly because we're going to end up erasing most of it. But that's the original parabola, right? But we only get to keep what? Yes. So we're going to end up erasing all of this up to -1 and the left. What else do I need to fix? This has a less than. I have to have an open circle here at -1, 3. It goes right up to -1, guys, so don't put it anywhere else. Yeah, that's not the right spot. Make sure it's right at -1, 3. And try to make them kind of big because I'm old and can't tell if they're open or closed, okay? Then what does it say to do for the next chunk? -1? Well, y equals -1 would be this line right down here. Which chunk do I want to keep of that line? Between -1 and +4. So I'm going to erase, well, I'm going to erase the whole thing because I didn't do a good job. From -1 to +4, it's just staying at -1. What about the endpoints? Open or closed circles? Okay, if you have this symbol or this symbol, it's closed. If you have this or this, it's open. So the -1 is closed, and the +4 is open. All right, now starting at 4, normally this graph, I'm going to graph a bunch of it here. Normally this graph, a cubic looks like this. Everybody with me? Okay, there's a reason we did transformations yesterday. What 2 transformations have occurred? Up 2. So right 5 and up 2 is where this thing is doing its cubic shape, okay? But we want to keep points that start with what? So like 4, 5, 6, maybe, if we want to try some points. If I put in a 4, 4 minus 5 is -1 cubed. It is -1, right? -1 times -1 times -1. Plus 3 is 1. 2, what? -1. -1 plus 2 is 1. Okay, my mouth and my eyes aren't working together. 5 minus 5 is 0, so we get 2. 6 minus 5 is 1. 1 cubed would be what? 1 plus 2 is 3. All right. So I don't need all of this. I need at 4 to be at 1. 5 to be at 2, but by 6 I'm at 3. Now it's looking linear. Is this, you're supposed to know that it's not a line, right? Because it's a cubic. So maybe we should do one more point. 7 minus 5 is 2 cubed would be 8 plus 2 would be, so if you go all the way out to 7, it's all the way up here already. All right, open or closed circle at 1, 4. Yeah, it was closed right here, so we're doing a little bit of exaggeration of the cubic shape there, but that's the shape it should have. All right, I do hereby solemnly swear it's not quite that complicated on the test, okay? I think it has a line and a horizontal, it has a horizontal line and a like oblique line, a slanted line. And then maybe a parabola piece or a square root piece, but that's it. It doesn't have all this complicated stuff that some of these do. All right. This is what I'm going to do this time. I'm just going to graph these and then we'll talk about where we're erasing. So you don't want to do this on your paper necessarily, but I need for some of you to really understand that this line is what? Tell me, you know how to graph that. Down at -5, then what? Up 1 over 1. Okay? So if I were using my line tool, because, you know, I can't draw, it would look like that. But we're going to throw some of that away in a minute. I just want you to remember how to draw these. What about this second one? Yes, and it would go through, give me some ordered pairs. 1 cubed would be, 2 cubed would be 8. So it would be doing this. Ooh, yeah, that's bad, but we'll do that. Does anyone know what this one looks like? Do you remember what? Anybody have their parent function sheet out? Yeah. Yes, it's one like this and one here. So put in a 1 for me. 2 divided by 1 would be, so we put in a 1, got out a 2. 2 divided by 2 would be 1. So it's in this and the same down here. Okay, now we have a big mess because almost none of that is right. All right, which part of the black line can I keep? Just the stuff less than 0. Okay, so if I erase this line, I want to keep the piece going which way? Down. Yeah, to the left or down. All right. Yeah, this isn't going to work because I'm going to have to erase things that are drawn on top of other things, but we'll get there. Open or close circle at 0. Close circle at 0. All right, the second one is the cubed root guy. I'm going to see if I can try to erase some of it. Which parts of the cube root do I want? Between 0 and 2. So I don't want this red squiggle over here. I want just this piece between 0 and 2, and I don't want an arrow. Okay, so between 0 and 2, what about the ends of it? Open at 0, closed up here at 2, 8. All right, then back to my little teeny tiny eraser. Which part do I want to keep of the cubic? Only the piece over here to the right of 2, so I don't get to keep any of this or this. And at 2, it's actually an open circle, right? And you can't tell, it looks just like a line. It's actually a little piece of a swoop. All right, yes, equally icky that we're not doing on the quiz. Now, I need to go back and talk about something on both of these. Where are the points of discontinuity on this one? Yes, at x equals -1 and at x equals 4, both places, this one was discontinuous. This one is discontinuous at both what? X equals 0 and 2. They are not always discontinuous. Sometimes they land right on top of each other, and then you just do a solid dot. All right, let's try this. Okay, what do you like better? Do you like just graphing the piece that we need instead of trying to graph the whole thing and erase? That's what I like better too. So what shape is this? Because that's important to think about ahead of time. So it's a parabola, right? And we want values from -5 and below. So give me a couple numbers. Okay. All right, let's try those and see what we get. Could you type it in your calculator and look for some values in the table? Yeah. All right. -5 plus 6 is 1. 1 squared is 1. -6 plus 6 is 0. -7 plus 6 is -1, but squared is still 1. -8 plus 6 would be -2. Squared would become +4. So -5, 1. -6, 0. -7, 1. -8, 4. Okay, is that a pretty good parabola shape? What do I have to be careful of? The one at -5, 1 should be what? An open circle. Anybody see why you should use pencil? Yes. It's a good question, but this says all values less than -5, so it's an arrow. It's not going to have an arrow on this middle piece because there's 2 endpoints to it, and the right end, this will have an arrow. Good question. All right, these are my favorite. It just stays at 7. So we're all the way up here at 7 from where to where? And what about the ends? Yes. -5 to +2. I still went too far. Okay. All right, now what? From 2 and greater, we're using this. Actually, what should we start with? 2, because that's going to be where the open circle is, right? So if I put a 2 in, what do I get out? 2. So at 2, 2, there's an open circle. If I put a 3 in, I get out 4 minus 3 is 1. Absolute value just keeps it 1. I put a 4 in, I get out. Oh, yes, not going up off power. Just kidding. So 2, 2, 3, 1. What did I do? Okay, yeah. Three, 1, 4, 0, 5 would be -1. You can't have a -1. Just kidding. What happens when it gets to 5? 4 minus 5 is -1, but the absolute value makes it 1. Now do we have the right shape going on? Yes. Discontinuous at -5 and +2. Right? Those are the places it jumped. All right, I hope we get one that doesn't have all discontinuous because that's what's on the quiz. All right, who wants to do the first piece? The easiest one. You gonna let Kevin do the easy one? Make him do a hard one. All right, do the easy one. It is horizontal at 4. And I start where? At -5. And I just keep going this way. So all values of x less than -5 simply stay at 4. All right, the second piece is an x cubed, and it goes from -2 to +2. Anybody cube those numbers for me? -2 times -2 times -2 is? -8. -1 times -1 times -1? 0, 1, and 8. So, -2, -8. These are both solid, right? This graph has a big jump, doesn't it? -1, -1, 0, 0, 2, 1, 1, just kidding, 2, 8. Well, that's a nice picture of a cubic in there. They were both solid because these are both or equal to. And then there's a big jump because we don't use the values until we get back to 3, right? So this jumped from -5 to -2. We had nothing. And then this jumps from 2 to 3. So again, if I put in a 3, what will I get out of this? Square root of 3 plus 3 is square root of 6. If I put in a 4, I get out square root of 7. I put in a 5, I get square root of 8. I put in a 6, I get square root of 9, which is the first nice number. Ugh. Okay. 3, and what is the square root of 6? 2 point something. Yeah, I'm just putting a big open circle there. And it is going up ever so slowly because it doesn't, until we get to 6, it's not even up to 3 yet. It is a curve, but ever so slow. Now do you see why I'm not going to assign the book problems much? Because they're just ugly. I'm not going to put one like that on a quiz because I can't tell if that's a line or not. All right. This is at the bottom of 7A. If you want to go back and fill it in your notes. The only one I think I'm going to do with a, excuse me, what is this called again? Anybody remember? Round down function. It's a step function. It's called actually the greatest integer function. Okay. But you remember what it looks like? It goes like this, okay, when we get there. So who wants the first piece? I'm down here at -1 until I get to what? To the left of -3. So I have that piece. The middle one here, 1 plus x is a what? It is a line. Would cross the y at 1, go up 1 and over 1, or down 1 and back 1. Which chunk do I want? Okay. All of that chunk I just drew, except what about my ends? All right, and then between 4 and 6, we're supposed to be drawing these guys. So if I put a 4 in, is it an integer? So at 1, 2, 3, 4, 1, 2, 3, 4. So at 4, 4 is where it starts. And it stays at 4 until we get to 5. Then it jumps up and it goes 5 over to 6. And if it stops at 6, it would actually just be a dot. Yep, never going to put that on a quiz. All right, do we have any nice ones on this worksheet? No, apparently not. Okay, so you have to do 4 of these out of the book, page 52, number 32, 33, 35, and 37. Okay, they're on the blue, it's on the blue assignment sheet, but it is page 52, 32, 33, 35, and 37. Okay, that's what the graph paper is for. Don't pack up though, because we're going to practice writing these now, which is 8.5. You didn't have a worksheet 8.5, so I named this one 8.5 so you'd know where it fell in your notes, okay? We have to write equations on the quiz as well. We have to write equations on the quiz as well. So, everybody grab this at the door? All right, let's start with this. This is an easy one. Number 1 isn't too bad. We need to come up with an equation for each chunk and then the restrictions for each chunk. I often do the restrictions first. Would that be okay if we just talk about where this back part for each one? Okay, so the first little chunk over here works from what to what? -5 to -1. So left to right, negative 5, x, negative 1. Okay. One of them gets a or line. Which one gets a or equal to? The negative 5. Good call. All right, so we got that chunk done. Not really. We still got to write the equation. We could do it. It's really easy. But let's just talk about this next chunk here. This next chunk starts at 1, and it goes to 1, 2, 3, 4. Is that right? Okay. So it's in between 1 and 4. And both are solid, so we have or equal to. And the last chunk out here does what? Goes on forever. It's supposed to have an arrow here. It's not included. It's open, right? It starts at what, though? 4 and goes to the right. How do we say values 4 and bigger? X is greater than 4. When you have in between, guys, if you're confused, when you have two ends, it's always less than symbols, okay? Least to greatest on those. All right, let's go back. This one's easy. What's the equation over here? The y value was staying at -2. So the rule here was just stay at -2. All right, let's do the green one here, this chunk up here, because that's easy. The rule there was to stay at, is it 5 up, guys? So we need the rule in between. So we need the equation of a line. Spent a lot of time on that the first week in this class, right? For a good time, we could find the slope and then use point slope. Could we just use the graph maybe? Can you tell, is the graph have an exact slope? Okay, so that would be 2x, right? Y equals mx plus b. We need a 2 in here. Uh-oh, why is my sound on? My daughter, I made a birthday cake for Miss Gupta and my daughter wants me to bring her home a piece. All right, not an emergency for sure. How do we find the b? It is not crossing y right now, right? But could we tell where it's going to cross y? If we backed it up one more time, where would it be, the y-intercept be? 2, 3, 4? Is it -4? Okay. If we weren't sure we had that right, could we test another point? Like right there is what, 0, 0, 2. No, that's 2, 0. Oh, that'll help. If I put a 2 in here, do I get out a 0? Yeah, that'll work. I was confusing myself for a minute there. We all know that I'm good at that. All right. Uh-oh. Want to do the little pieces first? Okay, where this chunk is all of what? Everything less than or equal to -2. The next chunk right here goes from what to what? Okay, do I need or equal to's? Not on either end. And then the last chunk goes from, yeah, it's 2 to the right, guys. So it's x is greater than 2, but it does have a solid, so it's or equal to. Just because the line's going down, that doesn't mean anything, right? The x values are going to the right, so it's still. Okay, now what? We do. This is actually part of your quiz, is finding equations of things. We already did this, though, with parabolas. Where's the vertex? Is it -4 or 5? -4, 0. So the equation looks like y equals x plus 4 squared plus 0, which we could ignore. 1, 2, 1, 2, 3, 4. Isn't it 4? Okay. And we have to figure out if there's a stretch. So we need to put another point in. You want to pick another point? -3, +1. Okay, so if I put the y value in here and then x value in here, what do I get? -3, it's just 1, right? This one doesn't have a stretch. So it's just a 1 here. So what are we going to write for our equation up there? It's already says f of x equals, I wouldn't count it wrong for that. Yeah, just x plus 4 quantity squared. And that goes with my red rule. I don't know why I wrote it in blue. Okay, just to confuse you. All right, what's the next piece? Can anybody tell?
A line.
It's just a line. What is its slope? Up 1/2. So can I just write 1/2 x? And it crosses the y at? The y-intercept is +3. Does that seem like the right equation? Go up to 3, up 1/2, right? That wasn't so painful. And this next line, the green one, I'm calling this, can you tell the slope? -2/1. And then we need to know if we were to continue it back this way, where would it have crossed the y at? Okay, so let's pick a point. What does this ordered pair look like right here? 1, 2, 3, 4, 5, 0. Does that work if I put it in? Yeah, right? All right, I'm going to do these the trickier way on the next one here. Well, maybe not on this one. All right, a little more practice. Who's got, I want the entire descriptor for this one. Who's got this? Dominic? Between what x values is it? -3. Yes, but least to greatest, it would look like this, right? And or equal, less than's on both ends. Either one of them need the or equal to. Okay. Then the easy part. Where is it staying that whole time? 1, 2, 3, 4. The y value is 4. Okay. Tristan, what two x values is this one in between? Any of those need a or equal to? Good call. Austin, can you tell me the equation of that line? What's the slope? What is it? Yeah, if you went from one end to the other one, up 3 and over 3, which would reduce to just 1x, okay? And where's the intercept? What's the y-intercept? So 1x plus 2, or just x plus 2. If we put in a 1, we'd get out a 3, which it's going through that ordered pair. Everybody okay? Well, let's do the easy part. What is this one doing? What are x values for this one? X is greater than 2. Do I need it or equal to? No. Okay. What is the parent function for that shape? It is square root of x. Has it been shifted left, right, up, down? To the right 2. How do you do to the right 2? Right 2. Remember, it's inside when you go left or right, and it's the opposite when it's inside, so it is minus 2. Just like a parabola, how it's x minus h. Okay? Now, has it been shifted up or down? No. But it could have a stretch, so we're really supposed to figure that out. I don't think it does, but let's pick this one right here. What is that ordered pair? 6, 2. So what do I put in for y? The 2. And for x? Okay. 6 minus 2 is 4. And the square root of 4 is 2. So I get the a is just 1. There was no stretch. So it's just square root of x minus 2. The one on the quiz, I think, just has lines. Okay? That you have to come up with the equation for. It's just lines, no goofiness. Want to try this one?
Yeah.
What are the x values for the first piece? -5 to -1. Do I need or equal to on either one? Okay, what about the next piece? Let's do the x's while we're at it. This one goes from -1 to +2. And then the next one goes 2 and greater, yes? And the middle one had the or equal to's. That's it. All right. Who thinks they can do one of them? They think they can at least get the equation of the line? What you got, Keaton? Okay, 1, 2, 3, 4. 1, 2, 3, 4, 5. That would take the square root and shift it to the left 5. Is everybody agreeing? Okay, so let's check a couple points and see if he's right. I put in a -5, I get out a 0, which is where it is, right? If I put in a -4, what would happen? I'd get square root of 1, which is 1. Is that working? Let's go to the other end. If I put in a -1, add 5, I get 4. Square root of 4 is 2. Seems like he's got it right, yes? He's just that good. Okay, what about the line? What you got, Kayvon?
I got y.
I think that's right. Right? Go through 1 and up 3 over 1, or down 3 and back 1. Okay, last one. Okay, it is a negative x squared, but the vertex is not at 0, 0. Where's the vertex? It is looking like a piece of a parabola. Does everybody get that? Whose vertex is at 2, 4? Is that true? So what would it look like if the vertex was at 2, 4? X minus 2 squared plus 4. And we're thinking it's that the stretch is a -1. I think you're right. If I put this point in, is that 1, 2, 3, 4, 0? So I'd have 0 equals a times 4 minus 2 squared plus 4. That would be -4 equals a times 4, which would make a -1. So yes, it's just -1 x minus 2 squared plus 4. Okay. They're not that hard on the quiz with the ones that you have to do the writing the equation of. All right. Tomorrow is a work day. We will have a packet. Anybody want it? The packet is Piecewise again. Does anybody want the packet today, or anybody going to be gone? Tristan, are you gone tomorrow?